Welcome to Mission Log 2 of the Clean Room, hosted by the University of Georgia's Small Satellite Research Laboratory. I'm Sharon, and I'll be your host today as we delve into one of the two current missions our lab is working on and get some insight from two very valuable members of the MOCI team. I would like to welcome Cameron and Divya.
Hi, my name is Cameron Bonesteel, and I'm currently the chief engineer for the MOCI mission.
Hi, my name is Divya Raghunathan, and I am a member of MOCI Flight Software.
A big thank you to Cameron and Divya and all of you in the audience for joining us for our second installment. On behalf of the SSRL, we appreciate all the positivity and support the Clean Room has received so far, and we look forward to continued community engagement. Now, let's get to know a bit about our guests and dive into the ins and outs of the MOCI mission. Once again, I invite our listeners to sit back, relax, and join us as we explore the SSRL's journey towards the stars. So the first thing I want to talk about is you guys. What are your current years and majors, and when did you guys join the lab?
Yeah, so I'm currently a senior graduating in May here, a computer science major, and I think I joined the lab back in the fall of 2020.
So, same as Cameron, I'm a senior, and I joined the lab in the spring of 2021, so a semester after him. And we both started off on the flight software team.
Yes, I have worked my way through a couple positions now, but my roots are in the flight software team.
Yeah. So what kind of led to you guys joining the lab? Were there any specific kind of opportunities you guys were really interested in, or what about the lab appealed to you guys?
Well, frankly, I didn't know the lab was a thing at the university until I got an email from the computer science department head, and it kind of sounded interesting. I'd always loved space, and I didn't know exactly what I wanted to do with computer science yet, and so I kind of just took the leap and applied for the lab.
Yeah, my story is almost identical to Cameron's. This was during COVID, right? So I had gotten that email. It was sent, my semester. And I was like, I like space. I like programming. I want friends. So I was like, hey, 3 birds, 1 stone.
So you guys both work on the MOCI project. Let's just start with talking, what does MOCI stand for?
Yeah, so MOCI stands for the Multi-View Onboard Computational Imager. Basically, that's a really fancy way of saying we have a couple cameras on board, and we're going to do some of our actual science processing on board the satellite as well.
Fun little fact, it used to stand for Mapping and Ocean Color Imager.
Really?
It changed because the scope of MOCI was made more complex, where we added our 2 cameras aboard MOCI. And so that's when it changed into the MOCI that we know it today.
What's the purpose of MOCI? Like, why did we start this?
So MOCI was kind of like a secondary project after Spock, which was, discussed in the previous episode. Go watch it. Listen to it. Spotify. But we wanted to be able to take accurate images of the Earth and be able to make sort of like topographical maps. They're not exactly topographical, but essentially it's used to just see the elevation levels and like make a little nice, easy map for us to detect certain structures and geographical formations.
Yeah, effectively, we'll be able to take a couple images of, let's say, like a mountain range from a couple different angles. And then through those images, we're able to basically reconstruct a 3D reconstruction of that mountain range. In addition to that, though, we're kind of doing a side project with the computational side of things and doing some testing with some machine learning algorithms on board. So I'm sure a lot of people have heard about object recognition. And so our goal is to kind of test our onboard computation by training one of those object recognition models on the ground and then just testing our computational abilities in space with the images we take.
And so that's where the super novel idea of MOCI comes in, where we have a GPU, a graphics processing unit that we're putting into space. And so for that GPU's lifespan, we're going to be able to process those images in space using the algorithms that we've trained on the ground.
What inspired MOCI, and do you guys know like where this idea came from?
Yeah, so kind of like Divya was saying, it started out as kind of a secondary Spock mission, really to kind of look at the Georgia coastline. But when MOCI moved from a 3U satellite to a 6U satellite, we kind of changed the scope of what we were doing because we had that 3U optical payload on board.
And so from that, we were able to make it a lot more complex, and we were able to move away from where Spock was spectral ocean, there was looking at the ocean. MOCI initially, like Cameron said, started out as looking at the Georgia coastlines, but then when we got a better camera and our payload got better to fit the 6U nature of MOCI, that's when the mission scope was upgraded.
Okay. So let's talk about the design aspect of MOCI, because it's a CubeSat, and I think it's a lot smaller than what people would normally think a satellite to be. So maybe let's just start with that. Like, how big is MOCI?
Yeah, so MOCI is a 6U CubeSat, and so for those of you who don't know what 1U is, it's basically a 10 by 10 by 10 centimeter cube, and so you can basically think it's about the size of a shoebox. 3U of that is our actual computers and hardware, and then the other 3U is our optical payload.
And so the cool part about CubeSats is, name cube, we can stack a lot of those cubes together. Not exactly stack, but if you wanted to picture it in a way, you can take each of these cubes of 10 by 10 by 10 centimeters and put them together to create 1U, 2U, 3U. There are 6Us like MOCI, and there are also some 12U CubeSats out there.
And so really kind of the benefit of that system is that it's all standardized, and there's a lot of commercial options for some of the hardware out there, which MOCI is using some of those commercial boards, but we can also create our own boards that are in that form factor as well pretty easily that fit that specification.
Tell me about how MOCI is going to work after it's launched, just everything.
So there are a lot of different phases that MOCI will go through in its lifespan. To start, MOCI, when it launches, it'll be put in a rocket with a bunch of other CubeSats. Spock was put on the Antares rocket from Northrop. And so we already have, the UNP will find us a launch provider. But when we're put up there, the CubeSat is slotted into a spring-loaded container, and the lid is shut. So the rocket is launched, we enter our low Earth orbit, which is where MOCI will be working from. The lid is opened and the spring pushes MOCI and a bunch of other CubeSats out. From there, there's a 45-minute window from MOCI being ejected to, all of our systems being functional, if we wanted to use fun space talk. And so in that period of time, we just need to make sure that we've reached a safe distance away from the launch provider and the rocket, and we're able to make sure we're not going to hit any of the other neighboring CubeSats. And so our radios go online, our antennas are deployed, we are ready to go. And so from that, we're able to get into the series of modes or states that MOCI works on, which Cameron knows a lot more about.
Yeah, so each mode you can kind of think of like a task that MOCI can do. So we have kind of just like an idle state that MOCI's in a lot of the time. And that state is supposed to be what we call a power positive state. So that way our satellite is charging and we know that we have adequate power to do our next task. And then we have three primary tasks that the satellite will do, those being our scan mode, data processing mode, and data downlink. So each kind of does exactly what it sounds like. Our scan mode is when we'll be overflying a target on the ground and taking images of that target. And then our data processing mode will take those images that we take and process them into our final data product. And then our downlink mode is then designed to take those data products and return them to Earth. This system's a little bit different than a lot of conventional satellites out there because right now, a lot of times they just take that raw data that they collect and they downlink it straight to the ground, and then all of the data processing is done on Earth. And so that's kind of one of the exciting things about MOCI that we're looking forward to is seeing how that data processes in space and what kind of results we get from that data.
The last broad mode that MOCI will go into is safe mode, and it's more like a recovery state when, some sort of anomalous error happens or anomalous activity happens in space for MOCI. We're able to put it in this mode, and it'll transition to this mode. And so our ground station operators will be able to say, oh no, MOCI's in safe mode. What went wrong? Let's see if we can really quickly diagnose the problem. And once that problem is all resolved, we're able to put MOCI back up into the mode that it was supposed to be in. Additionally, another cool thing about Satellites they have something called the ADCS, the Attitude Determination Control System, and it's used, they have active and passive ADCSs. MOCI has an active one, which just means that because MOCI's taking pictures, we need it to always be nadir pointing, which just translates to it needs to be pointing perpendicular to Earth. So it must be looking down at all points in time at Earth properly to take those pictures. And so we have the ADCS, which operates on an XYZ fields, and we have reaction wheels that operate off of the third law, which is the equal and opposite reactions. So every time it'll spin, it sends it in the opposite direction, which is how we control the movement and the really, really fine pointing of MOCI. And it's how the fine pointing works in CubeSats in general, or satellites.
So really we're able to use that to, go through all of our modes and take the images of the targets that we want, but also point it at our ground station to downlink our data. But also the cool part is at the end of life, we'll also use the ADCS to point the biggest face of our satellite into the orbit. And so that way we have the most atmospheric drag on the satellite. And so we deorbit faster than we would in a normal orientation.
So I guess maybe you guys can just tell me about your personal experiences, what kind of things you guys do. Cameron, I know that you are the chief engineer right now on the project. So what kind of things do you have to do or get to do?
Yeah, so really the role of the chief engineer on the mission is to oversee that all of the teams are meeting the requirements set forth not only by us, but by our client, the University Nanosatellite Program, as well as any of the CubeSat design specifications that are out there. And so those requirements were set forth at the beginning of the mission, and some of them are technical based, like we have to use a certain type of epoxy or glue to make sure that we're using space-safe materials, or it could be something more broad about like the mission and saying like we're going to make sure MOCI's mission lasts X amount of time. And so really, I'm not necessarily an expert on every single subsystem on a technical level. Like I'm not an electrical engineer or mechanical engineer, so I'm not entirely sure how some of those systems work in their entirety, but I'm able to ask good questions to those teams and be critical of their design to make sure that we are meeting those requirements, because the requirements are pretty straightforward and easy for even people who aren't electrical engineers or mechanical engineers or software people to understand the requirement and make sure we're meeting them. It's just to provide that technical guidance in the places that I can and make sure we're on track and meeting all the requirements that we need to launch safely and successfully.
Divya, you are on the flight software team. So what kind of stuff do you do?
So I've been on the flight software team for a little while now. And so I work really closely with our current flight software lead. I help out with a lot of the flight software tasks. So previously, I did work on a certain board, and then in addition to that, I worked on a specific little chip on there. And in addition to being a flight software member, I'm helping with a lot of our flight software tasks, and I work on our testing satellite. So I get to test out a lot of the components. I get to help out members test their components. I also interact pretty closely with the MOPS team, and so we get to learn a lot about how the mission operators are going to work and how the software we write is going to be used and how the ground station will be able to communicate with the satellite using our software. And so it has really fun applications. And so working on flight software gives us the really neat perspective, being able to see like what the functions actually do and what each board's function is.
What kind of challenges, difficulties have you guys faced, I guess, working on this specific project or just in general, working in the lab?
So I'll hop in. The really fun thing about MOCI is we have a few pre-built boards, and pre-built, like we've bought them from a supplier or an existing company that makes these boards. And so with that comes the problem of if one of these boards doesn't work, it's not something that we have made. And so it's not like we can say, let me see what sort of problem it is. Like, let me look in our build design, or let me look in the code and let me figure out what's wrong. A big problem in flight software is there's a lot of like proprietary software and proprietary things that we have to go snooping around for, and we have to be in contact with the companies for. And especially we're writing in a flight software development kit. We're writing using it. And it's really confusing. And the documentation is a little iffy. And so we have just a lot of problems when it comes to interacting with companies. Like a funny story, a little brief aside, we had a question about our GPU. We emailed the company and we asked them, hey, we're doing this. Can you help us out with this problem we're having? And we got back a really, really simple response, which was, putting this GPU in space will void your warranty. And so it's stuff like that where we're just interacting with these companies that really don't want to help us too much.
Yeah, I don't know. For me, as the chief engineer, I really have an oversight of everything that's going on in MOCI. One of the things being a university program, we get a lot of turnover with people graduating and new people coming in. So we're always training new people, which isn't necessarily a bad thing. I mean, that's why we exist. We exist to get university students into the aerospace industry. But from a standpoint of trying to get a mission into space, that can be pretty challenging sometimes because a lot of our engineers who've been with us 3 years now or 4 years now are training and they're on their way out. So now they're either going to take knowledge with them or they got to write it down and, make sure it lives on through the people before them. From my position of trying to get the mission launched, that's definitely a challenge that exists.
No, I think that's even something in our previous episode that was mentioned, is that we've just had a big loss of knowledge, I think, with people graduating and stuff. So I can imagine that would be difficult kind of dealing with. Well, I guess in terms of our next step forward with MOCI, as far as like launching goes, do we have a time frame for that? Is there a specific date?
Yeah, so we don't have a specific launch yet. Really, the goal right now is to finish up our engineering model, make sure all of our software, hardware, actual frame of the satellite, all those sorts of things have been thoroughly engineered, we're critical of our design, and that they work as we expect. Currently, we're hoping to have our engineering model done no later than October of this year, so then we can present it to the University Nanosatellite Program, and then hopefully they'll give us permission to build our actual flight model. And with all that building and testing that needs to be done there, we're hoping to basically be flight ready by May of next year. And so flight ready basically meaning that the second we get a launch and the launch provider says, hey, your satellite needs to be on site by this date, we can get it there by that date.
So I guess once it is launched, how long will MOCI be in space?
MOCI has a 3 to 5 year lifespan, and so it's going to go around the Earth and make as accurate of a model as it can in that time. But the GPU that does the image processing has only been flown very few times. It doesn't have a history of withstanding radiation, and it's not built to withstand the radiation from space. It's meant to be put in a computer on Earth. We anticipate that the lifespan of that GPU is 6 to 9 months, and once it stops working, the satellite and the ground operators will be able to say, okay, we're not going to use the GPU anymore. We're just going to send our raw data back to Earth via the radios. And so our ground station on Earth will be able to process those images the same way, hopefully, that it does in space.
Wow. That's really exciting.
Yep.
Wow.
Yeah.
Yeah, hopefully May of next year we'll be launch ready. So
Keep an eye out for it in your local news publications, meaning the Red and Black in Athens.
That is awesome. I just have a couple more questions for you guys. I guess in the long term, for just small satellite technology in general, where do you see this going in the future?
yeah, so I'm actually really excited about the idea of using more like high-level processing units in space, mainly because we've kind of been living in the 70s when it comes to our processing capabilities. The main computer on MOCI only has 8 megabytes of RAM. For those of you who wonder how big that is, your phone has 8 gigabytes, which is basically 1,000 times larger. So the processing capabilities in space is pretty limited with what we're comfortable with. And so the more we have missions like MOCI that put GPUs in space and do that like higher level processing, the more we'll have the opportunities to test artificial intelligence in space and maybe one day make a satellite that can make its own decisions when it's, outside of the reach of our communications. Because that's been, another issue that satellites have had for a long time, especially with like deep solar system missions, we lose contact with them and we can't tell them what to do. And so we kind of just have to hope that they're doing their mission. So if we can intelligently make decisions, it can get us better data than whatever we pre-planned for it.
Another really cool thing about CubeSats is since they're so small and they require a smaller overhead in comparison to an actual big satellite that requires like billions of dollars, CubeSats are really simple comparatively. It's a comparatively simple way of testing new things in space and doing new things. So like we're putting GPUs into space, like Cameron said. Testing AI. NASA has been hurting for better, accurate maps of Earth's surface and in space. So we want a lot more things that CubeSats can help with. And since each CubeSat is so small, we're able to dedicate specific tasks to each CubeSat. And so we can accomplish a lot simultaneously when we just have a bunch of CubeSats doing really cool different things. And so I see that the formation of all of these, of the University Nanosatellite Program and of all these initiatives to increase CubeSat visibility and helping schools get working on CubeSats and getting engineers and computer scientists that can work on them in the future for NASA and other aerospace companies. The future is looking really, really bright in terms of space aviation.
You guys both mentioned that you're seniors, so you're graduating, and you've both been a part of this lab for at least 2 to 3 years. So I guess I just want to hear about what you feel is the most rewarding aspect of your experience in the lab, and maybe even how it shaped your plans for the future, career-wise.
Yeah. So kind of like I said earlier, I didn't know what I wanted to do for the future. And so coming into an environment where really there's not a person that I've met that I haven't liked in the lab, everyone's so friendly and are so knowledgeable, and I learn a lot from everyone, and I've made good friends here. And so really that just left a positive experience on me, not to mention, my enjoyment for space. And so really I just fell in love with the idea of writing software for satellites. I'm happy to say that I do have a position after graduation doing just that. So it really drove me to the first job after college that I have today.
Congratulations. Oh, what about you, Divya?
Yeah, so in the same way, I accomplished one of the 3 goals that I set out with, which was make friends. Everyone at the lab has been so knowledgeable, and they've all been so indispensable in learning so much about engineering, computer science. I became 10 times the programmer that I was 2 years ago. And it's all thanks to interacting with the people of the lab who are all so smart, and they're so knowledgeable. And the greatest thing is everyone is willing to talk to you, and everyone's willing to teach you. And so it's just been such a positive environment where knowledge and growth and, just it's all been promoted so well. And so the culture of the lab really lends itself to being very productive. And so it's thanks to that, right? I've become a lot more confident in my coding ability. I've started understanding a lot more of the engineering topics, which is something that I never anticipated. It really has changed the way that I thought my life would go. I came in as a finance major, so I thought I was just going to go do a finance job. And now, after working at the lab, I cannot see myself doing anything that boring in my eyes. Now it's, oh man, I want to work on a satellite again. And so when I graduate, that's going to be the first jobs that I'm going to look for.
Wow.
You just offended a whole bunch of finance majors.
I'm allowed to offend finance majors. I am a finance major.
Thank you guys for giving us the inside scoop on the MOCI project. Now I would like to introduce a new exciting segment centered around space news. Today, this segment will focus on NASA's recent crew announcement for Artemis 2, which will be the first crewed mission on the Orion spacecraft in a deep space environment. This mission and the Artemis program serve as an effort towards returning humankind to the moon's surface. On April 3rd, NASA announced their selected crew members: Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Hammock-Cook, and mission specialist Jeremy Hansen. Can you guys tell me about the Artemis mission?
The Artemis mission it built off of the first one. So this is Artemis 2. Artemis 1 launched November 16th, 2023. And that was unmanned. And so all this is the Artemis project is, making steps. So that was an unmanned mission around the moon. It came back in a similar way. Artemis 2 is a manned mission. And so we're going to send people up and we'll do a little fun figure 8 where we go into space, we go around the moon, and we come back to Earth. And so it's just meant to reestablish our connection with the moon, if I wanted to put it in a funny way. And it's meant to say, hey, we can actually go back. We're not stuck on Earth anymore, because it's been decades since we've even messed with the moon.
Yeah, and I think the really exciting thing is, during the first Artemis mission, not only was it sending the Orion spacecraft around the moon to kind of test that it had the longevity to get there, but also there were some cube satellites on board that as well. And that was in an effort to start doing satellite research around the moon as well. I think there was initially some problems with some of those CubeSats and those sorts of things, but that's kind of expected considering that's the first time we've put a CubeSat out that far, and really the first time we've been out that far in the past couple decades with a spacecraft like this. So really this Artemis 2 announcement and, us getting closer to launching the Artemis 2 manned mission makes me really excited, because that means that I am in my lifetime going to see someone on the moon again, which I always thought maybe I was born in the wrong decade, not seeing a man step on the moon. But now that's happening, in my lifetime, I'm really excited again. And, I'm excited for where it can take us in the future too. Because the other exciting thing as the moon kind of as a stepping stone for the rest of the solar system is on the last Artemis mission, there is actually a cube satellite that was going to test the Gateway orbit. And so for those of you who don't know what Gateway is, it's basically going to be our gateway to the rest of the solar system. It's a space station we're putting around the moon where we're going to be able to do refueling operations and resupply operations in order to get us to Mars and beyond as well.
So, like Artemis 1 had the CubeSats, Artemis 2 also planned to have 6 and 12U satellites aboard, and it would have been ejected the same way on the moon. But it was actually scrapped in 2021, and so it's a little sad that we're not actually going to get to see any new CubeSats being launched, but I think it's good because it'll give us more time. The Artemis 2 mission, it's only meant to be a 10-day mission, and so I think with the astronauts doing their job, they're going to be looking at the vitals, and they're going to be looking at all of what's happening. And so using that data that they've recorded, all of the data that they've recorded will be really useful in making sure that when Artemis 3 or any future missions go up, we're able to have a better understanding and a better idea of the conditions that the CubeSats need to face.
And to protect astronauts, because, the space environment's pretty volatile, and the moon doesn't have an atmosphere to protect them like the Earth does. And so, there's been steps to redesign the spacesuits, because the ones that they used to walk on the moon almost 5 decades ago now, they were pretty bulky and hard to move around in. So I've heard, I haven't experienced that, but, So, yeah, there's a lot of research and improvements to be done if we're looking to put humans in space long term.
Even though we're not going to actually set foot on the moon in Artemis 2, it's a really, really good sign, right? So as we're making these steps, we're moving more and more towards, the next mission, people will be on the moon. And using these missions, it's just symbolizing that there's a really renewed interest in space exploration, and there's a new priority that's been set on exploring outer space and seeing what's beyond us. And so I think it's a really good sign, and if NASA can pull it off, I have a lot of faith that, it'll go great. These are all really, really good signs for the future, where perhaps in our lifetime we'll be able to see someone on Mars. Perhaps we'll be able to have a colony in space. I don't know if I'm the biggest advocate for space colonization, but I think it again is really cool. And if I think we find a way to, inhabit other planets other than Earth, it's just these are like massive steps for humanity.
And I think, too, you mentioned, this is kind of a sign of renewed interest in space, which I'm particularly excited about because, I think for a long time people were wondering why we should even do space research. And my argument to those people would basically be that we've had a lot of everyday inventions come from space. The zipper, Velcro.
Freeze-dried food.
Yeah, all those things are things that have come directly from the space program. And so even our continued involvement and funding of space research, whether it be satellites or putting people on the moon again, we're only going to learn more about not only the solar system, but about even our own planet and, develop new technologies along the way that can improve everyday lives.
I know that there previously, I'm pretty sure, cochlear implants, where the development of cochlear implants was aided by space and discoveries made in space. So I think there are a lot of really broad applications where data we gather in space and things that are created for space will be really useful. And so it's just, these are all really good signs. And I think that people that are saying there's not really a need to explore space. There's a lot of really cool things that don't happen on Earth that do happen in space. And so I think as we've learned more and more, and as we grow, as science also grows, so the bounds of science are increasing day by day. And so why shouldn't it include space, is what I would say.
Well, it looks like it's a really exciting time as far as space travel goes and space exploration. So I guess we will stay updated as far as that goes. But thank you guys for coming to speak on the clean room. Before we wrap up, are there any final thoughts you would like to share?
I just wanted to say it's been a pleasure. I really, really enjoyed telling you about MOCI. It's something that both Cameron and I can talk about for hours at a time. And so we're both really honored that we were invited to speak on the Clean Room. And I'm excited for our future episodes.
Well, that concludes the second episode of the Clean Room. So join us again next time to hear from the MEMSAT team about the SSRL's third satellite mission. Sharon Isaac signing off.